This is the solution video for question 16 from paper 1 of the 2019 TMUA or CTMUA exam. In this question we're given that the integral of f of x between 0 and 1 times 2 plus 5 lots of the integral of f of x between 1 and 2 is 14, and we're also given the integral of f of x plus 1 between 0 and 1 with respect to x is 6. And given all this information, we're asked to find the value of the integral of f of x between 0 and 2. And we're given a few options for this. We're given 8 possible numerical answers. The first thing we can look at when we do this is we see this, the integral of f of x plus 1 with respect to x is 6 over 0, 1. And you'll see these two equations don't look particularly linked, so we need to write this out in a somewhat different way. So what we can actually say is the integral of this, if you've seen integration by substitution, if we put y equals x plus 1 in, then you'll see that we can get this fairly easily. But even without integration by substitution, we can justify this graphically. So here's a graph of f of x, and we see it between 0, 1 and 2 and a bit further both ways. So we're going to start on the right hand side because it's easier to imagine what the transformations are. So what does this mean? Well, it's the area under the graph between 1 and 2, namely this bit shaded in green. So now if we consider the integral of f of x plus 1, so x plus 1 means we translate to the left by 1, so our graph now looks like this and our corresponding area moves to here. And we see that if we wanted to work out this area, we take the equation of this graph, which is f of x plus 1, and integrate it between 0 and 1. So we see by a translation that this area is the same as this area, and so these two integrals are exactly the same. So with this knowledge we can proceed readily. So what do? Well, we see we've got this equation up here, but we know what the integral of f of x between 1 and 2 is, because we know this is 6 and this is this, so this is 6. So substituting that information in, we have 2 lots of the integral of f of x between 0 and 1 with respect to x plus 5 times 6 is 14. So doing 14 minus 30 to get minus 16, we get the integral of f of x between 0 and 1 with respect to x is minus 16 over 2, which is minus 8. We're asked to calculate this, the integral of f of x between 0 and 2. So let's split that up. So we can do the integral between 0 and 1 and 1 and 2. So now we know the integral between 0 and 1, that's minus 8. And the integral between 1 and 2, well, we know it's this, the integral of f of x plus 1 between 0 and 1, which we're told is 6. So we know we need to do minus 8 plus 6, which is minus 2. So looking at our answers, we see this chimes and matches with C. So our answer is C.